Hello everyone, my name is Vishal Shah. I'm a product marketing manager and general manager for Automotive and Display Driver business unit. And today we are showing our display driver solution for the VR market. There are two demos in this. On the left right now here we are showing our latest generation of display driver for LCD displays called R63457. This is for LCD displays supporting up to 3K resolution and 144 hertz refresh rate, and it has also our state-of-the-art local dimming technology, which provides OLED-like contrast ratio on an LCD display. So the main highlight for this one is it supports high resolution up to 3K, which provides a broader field of view, as well as to reduce the motion blur, very high refresh rate up to 144 hertz refresh rate. And now if we look at that, right now the local dimming is enabled, and Kishi-san will disable the local dimming. So now the local dimming is disabled, and you can see the blacks are no longer black because now the backlight is all on at the same time. And you can see even if the display is black, because of the backlight leakage, it looks gray. And now we are enabling local dimming, and now the blacks become deep black as well. So that's the benefit. The contrast ratio improves quite a bit by enabling local dimming on this solution.
On the micro display, to do local dimming, it's very small zones.
These are very small zones, correct?
How
yes.
small?
These are less than 2 millimeter pitch size of the zones.
And it's instant, very efficient, very bright, very...
It provides brightness benefit, and also provides contrast, and also provides power savings. For VR, mobile applications like VR, where battery life is an important aspect, the local dimming provides that power savings by disabling the backlights, which are not being, does not need to be on because of the black display. So, and it reduces the motion blur as well, because you're getting better contrast, you're getting the higher refresh rate, you're getting more pixels through the pipeline with high refresh rate, so it reduces the motion blur, and now you can just have a much broader field of view, which provides more immersive experience.
And the shape is like an hexagon, or what do you call it?
The shape is hexagon, but it can support freeform display. It depends on the UI or actual ID design. So depending on OEM requirement, it can be any shape and size of the display. So.
Is there a limit how much brightness you want in a VR display?
It can go much brighter. Given the LCD, it can go as bright as 1000 nits or 2000 nits. It's a function of battery life as well. So because it's a very near eye application, you don't want too bright, but you don't want it too light as well. So we can drive it as bright as it needs to be.
And so that's the LCD, and you're doing the OLED.
And we are doing the micro OLED as well. So LCD is more of a mainstream, kind of a not super expensive display. This is micro OLED. This is a 4K micro OLED silicon backplane, chip on silicon backplane. So this is a 1.3 inch display using our micro OLED display driver 66471, and enabling premium experience, more than 3000 ppi, and also extremely high brightness as well. It can go up to 10,000 nits brightness, so extra bright displays.
What do you think is going to be the biggest market, the OLED or the LCD?
So there will be market for both of them, because one is for the mass market and one is geared towards premium. LCD is more mainstream, a little bit lower cost, so it's a more economical from display pricing point of view. Micro OLED today, it's still in the initial development technology wise, so it's very expensive. So there is a market for both of them, where majority of the market stays with LCD.
And what has happened the last 6 months since the display week?
So since last week, we of course have a much more tuned display. So now we have a better overall display performance, overall better user experience. Display tuning has been the major focus for us. Same thing for the micro OLED. It's just we had a chance to go through more and more tuning, and then getting better user experience out of it.
Because it's actually extremely important to have quality improvements.
Absolutely, and that's where initially you didn't have any local dimming, But now, even with LCD, you want the higher quality. That's where the local dimming becoming more and more important to have the better contrast. Because at the near eye application, you want to have a very good display experience. So local dimming is important.
Is it similar to the local dimming for bigger displays?
It's similar technology. Of course, it requires a different tuning, different processing flow, but it in the background, yeah, overall thesis is the same, that we enable, disable backlight depending on the image content. How we do it, it's depending on the display type and display technology.
I guess when it's a micro display, it's much more challenging to manage the heat compared to a bigger display.
True. On the micro display, where especially for micro OLED, it does not have any backlight. So yeah, it has a silicon backplane, very active backplane. So yes, low power solution from display driver becomes extremely important, and that's where we provide a lot of valuable insights in terms of lowering power consumption, heat dissipation, while maintaining the display brightness and the performance.